This video is going to cover Chapter 11 in the Base Certification Guide. Really, the heart of this chapter is about by-group processing and the retain statement. And this part is probably one of the most useful parts of all of SAS. It doesn't exist in SPSS to my knowledge. You can't really do it in R. The only place where you can do this sort of stuff is in Python or Perl. So this really differentiates SAS and makes it one of the best tools for preparing data sets. I use by-group processing all the time in my work. The basic heading of this chapter is how to manipulate data in a data step, and they talk about a couple things in the beginning of the chapter that we've already talked about, but just for completeness sake I'll mention it. So this is all just kind of a warm-up to get to the real meat of the chapter, which is retain and by-group processing. So let's first talk about these other things. Sometimes you want to create a subset of a data set. So I'll give you a little example of this. I used to work for a company where we did a syndicated marketing research survey of about 50 different markets in the US. And then we'd have a client come in and want us to look at only 3 markets, say Chicago, Denver, and Oklahoma City. Then I would create a data set that had records only from those 3 markets and do all of my analyses because it'd be more efficient than working off the large data set each time. So how would I create such a data set? Well, the answer is I can just use an if statement within a data step. So if I say if x less than 50, what that means is we're only going to keep records where x is less than 50. If you leave the then off, what that implies is just keep these records. A completely equivalent way of doing this would be to write something like this. If x is greater than or equal to 50, then delete the record. So this is, it's the opposite expression up here and then the opposite action. So those are 2 completely equivalent statements. So subsetting data means you're just keeping certain rows in a data set. Very often you want to drop certain columns or keep only certain columns. And the way you do this is with drop and keep statements. So if you want to subset the data, if you will, by retaining only the columns x and y, or so by dropping x and y, you just say drop x, y. If you only wanted to keep a, b, and c, this is how you do it. Let me now give you a few examples of these. So let's say that we wanted to create a new data set from the employee data set that had only females in it. How would we do that? Well, let me translate the code for you. Data females means I want to make a new data set called females. I could call it whatever I want. I'm going to populate this by setting this existing data set called employee. And we're only going to keep records where female is equal to 1. And so if female equals 1 means keep only those records. If we run a frequency distribution on this data set we just created, what you'll see is that sure enough female is only equal to 1, and we now have 28 cases rather than the 71 that I think was an employee. An equivalent way would be to do something like this. If female not equals 1, then delete it. So female not equal to 1 is the opposite of female equaling 1. And if we delete all cases where it's not a female, that's the same thing. I should mention for completeness that if I were just going to be running one proc off of the subset, it would be more efficient to use a where statement. So you can stick a where statement on any proc in SAS that I know of. And so that says keep only these records. And so the reason this is more efficient is if you do a data step, then the proc, you've got to take a pass through the whole data set, then you've got to take a pass through the subset to do the analysis, where this is just going to do it in a single pass. So it would be more efficient. How do you drop variables? Well, for example, let's say we wanted to make a new data set that had only these 3 columns in it. Well, we would do that either with a keep statement, keeping those 3 columns, Or alternatively, we could do a drop of all the other columns. So in general, if I have a very wide data set with many variables and I'm just keeping a couple of them, then I would use the keep statement. If I wanted to, if I wanted to keep most of the variables in a data set and drop a couple of them, then I would use the drop statement. So it doesn't really matter, but I tend to use the one that's easiest for me. Let's go into by group processing. Very often we get data sets that are organized into chunks, some sort of chunks. Now the most common way to chunk it is by like a customer ID. So for example, we often get a transaction file where we have one record for every transaction that a customer has made. So here's a simple example, the most simple transaction file that, that I could come up with and illustrate the main points. So in this transaction file, customer 1 you'll see has made 2 purchases, one for $10, the next for 20. Customer 2 has made 3 purchases, and customer 3 has only made 1. Now, to illustrate by group processing, let me walk you through a little example. I'm going to make a new data set called new data, and we'll set the example in it. So nothing new there. What's new is this statement. We're going to do this by ID. So this is going to identify that there are chunks of observations that hang together, identified by this ID variable. Now, when I have a by statement like this, I can identify the first and the last record within a chunk, and that's very useful to me. So one of the things we'll be doing with this in a minute is creating RFM data sets. So the way we identify the first or the last record is with first dot and last dot processing. So you can prepend the SAS reserved word first, then dot, and the in a by variable. So in this case, my only by variable is ID. This expression first.id evaluates to true whenever it's the first record in a chunk and false otherwise. So just to illustrate this, I'm going to make a new variable first.rec that is yes whenever first.id evaluates to true. Otherwise, this is no. Likewise, we'll make another variable called last.rec that is yes whenever it's the last record. So if we look over to the right, what you'll see is that, okay, for the first record of customer 1, sure enough, first rec is no, last rec is first rec is yes, last rec is no. Second record, it's just the opposite. And then if you look closely at customer 2, it's what you would expect. So the first record, we get a yes, last record, we get a yes over here on last rec. Customer 3 only has 1 record, so therefore you get 2 yeses. Let me give you a little example of why you might want to do some of this processing. So, problem is, let's make a data set that has a list of all unique customer IDs. Well, one way we could do that is just with a by statement. So we're going to set example by ID, and we're only going to keep the first record. Now, there's no reason to keep amount here, because why would we want just the amount of the first purchase? It's hard to come up with a good reason for that. So let's keep only ID, and you get to see a nice example of the keep statement. So here's the result. We find out that there are 3 unique customer IDs, 1, 2, and 3. One little note: the variables had better be sorted by the by variables, otherwise you'll get an error message. I'm now going to make that example a little bit more complicated. So suppose we wanted to find the monetary value of each of our 3 customers in that previous example. What we have to do is keep a running total of the amount. So we're going to do that with the retain statement. So the retain statement will enable us to keep track, to keep a running total of amount. So retain simply says this: retain the value of a variable across observations. Normally when you go to a new observation, variables get set to missing. Any variable that's listed under a retain statement maintains its previous value. So I think this will make sense if I walk you through a little example. Let's make a new data set called data3, and we're going to set examples. So there's nothing new with these first three lines. What's new is right here. We're going to make a new variable called monetary, and I want SAS to retain its value across observations. In the next statement, whenever it's the first record for some customer, so if it's the first record for this customer ID, then we're going to initialize monetary value to 0. Otherwise, it doesn't get overwritten. Then we're going to set monetary equal to monetary plus its previous value. So let's see what happens. For the first record, come in, and since this is the first record, monetary is going to get set equal to 0. Then if we go to the last line, monetary gets incremented by amount. That's why monetary is equal to 10. So that 10 is really 0 plus 10. Come to the second record. Is this the first record? No. Therefore, monetary does not get initialized. It retains its old value. Then increment monetary, set monetary equal to previous value plus amount. So if we take 10, this 10 plus this 20, we get 30, and that's why the value is 30. Let's go on. For the next record, we come in, and if it's the first record, which sure enough it is, then monetary gets set to 0. Then monetary is 0 plus the amount, which is 5. That's why monetary is 5 here. Next record. Is this the first record for customer 2? No. Therefore, we don't have to initialize this to 0. Retain the old value, which is 5. Now set monetary equal to the previous value plus amount. So we're going to take this 5 plus this 3 to arrive at 8. Next record. What happens? Well, is this the first record? No. Therefore, we're not going to initialize it. And then we will take the previous value monetary, 8, add to that 2, and we get 10. Next record is for customer 3. Is this the first one? Sure is. Therefore, monetary gets set equal to 0. Then what we're going to do is take the previous value monetary, which we've just set equal to 0, and add to that the amount, which is 40. Therefore, we get a monetary of 40. Now, there's one issue with this particular example. If we want monetary value, we're not going to want all these intermediate records, so we would want to keep only the last record. So I'm going to add 2 statements to that previous data step. One is an if last.id. So what that means is we're only going to keep the record. We'll only output this if it's the last record for that customer. And then there's no reason to keep amount, so we'll just keep ID and amount, and this is what you get. So that's kind of the simplest use of retain to create an RFM data set. Let's make it a little bit more complicated. So let's go look at that nonprofit data set that we've played with in the past, and I'll print the first 20 or so observations. Let's print it by ID, and we're going to add up the amount. So customer 18, you'll see, made 2 donations for a total of $15. Customer 935 made 3 donations for a total of $315. 1347 made 4 donations for a total of $315. Okay, so how would we make an RFM data set? Here's the code, and you want to get really good at this. I've probably written this code couple hundred times in my life. It's such a useful chunk of code. Okay, so let me walk you through this code. We're going to make a brand new data set, call it RFM. We'll set the old nonprofit data set in here. Going to do it by ID, and I want to retain RF and M. Now, if it's the first record for the customer, then I want to initialize these variables. We'll set recency to missing. frequency to 0, monetary to 0. Okay, so the do end block means do these three statements whenever you have the first record. Now I'm going to create a new variable diff. So diff is the distance, number of days between today and the gift date. So gift date was that date of donation that you saw in the previous slide. All right, let's pretend that today is January 1st, 2007. So let's take the date constant, that date within quotes with a D after it indicates a date constant. And so SAS will evaluate this to the number of days between this date and January 1st, 1960. I'm going to subtract off gift date, and that's going to give me the difference between those two dates. Now, if recency is missing, so it's missing the first time through, or if this difference is less than the existing value of recency, we're going to set recency equal to difference. Okay, every record is a transaction, so we're going to increment f by 1. F is equal to f plus 1. Monetary gets incremented by the amount, and then we're going to output the record only if it's the last record for the customer. Finally, we don't want to keep a lot of variables that really don't have any meaning anymore, like amount and source and all that. So we're just going to keep ID along with RF and M. And here's the result. So we should check and make sure we did it right. So customer 18 had a frequency of 2, monetary of 15. Let's just go double check that. Sure enough, that's what we had on this previous slide. Cool. Customer 935, frequency of 3, monetary of 300. And sure enough, that's what we get. So it appears that my code is working. So again, practice this on your own. Try to write an RFM, try to write this program on your own without looking at mine, and if you get stuck, go look at mine. Okay, that's it for the retain statement and bytecode.